of StateFlow. So I'm not going to explain what state machine is. Went over that with the people that are here in front of me before, so I don't want to bore them with it. So what StateFlow is, it's a built-in function of Simulink. Just like how Simulink is a part of MATLAB, StateFlow is a part of Simulink. It came after Simulink, just like how Simulink came after MATLAB. MATLAB's been around since the 90s or something, so it's evolved a lot over time. But the reason that they developed it is because state machines started becoming a lot more common in controls, and I have no idea how to code a good state machine in actual code, so I'm really glad that StateFlow exists. There are ways that you can do it and actually I can pull one up for the guys that are here in front of me later, but I have a really good example of why you want a StateFlow and not enabled subsystems, which is how you probably would have had to do it before. I'll attach that to this PowerPoint or something. Anyways, so the way that you actually get a StateFlow, if you're in your Simulink library browser, you can come down here in your toolboxes, and there's one that's just called StateFlow. Well, you can use truth tables and other things. In general, what we use is just a regular old chart. You just click and drag it in, and if MATLAB doesn't crash, it should just generate a new one. Awesome. Alright, so as you can see, I have a chart like a subsystem. It's something that separates a lot of logic into a completely different layout so that it's not cluttering other things. But you can see I don't have any inputs or outputs right now. I'll go over how you actually add those and use them. So if I go into my chart, you can see, you can always tell when you're in StateFlow because it'll have this yellow background. It might be difficult to see on the monitor. Hopefully the video captures this properly. But it is very yellow compared to this white that you would see in regular MATLAB. You can change that if you want, so maybe it's not white for you guys, but should be by default. So you'll also see over here on the left, it's added a whole bunch of other items that you don't see when you come back up. So that's where pretty much all of the StateFlow items are kept. You don't use the library browser to pull things into a StateFlow chart. There's a lot of very basic items that it's all about how you combine them that actually creates how something's going to work. So what actually are they? So this first one here, if you stay over it, you'll see it is a state. I click and drag it in, and it starts with just this little question mark. And the other thing it starts with is this little guy. So what that is, you can see it's also on the left here. That's a default transition. So you always need one of these in a StateFlow block. If you don't include that, StateFlow has no idea what state it's supposed to start in. So if we look at my other model here, you can see I have one, but I immediately put it into a little node here and test some stuff. You don't necessarily have to do that. You can just take your default transition and put it directly onto a state. So that is just a requirement of StateFlow. I'm not exactly sure what it means code-wise, but if you don't have it, StateFlow will not work, especially as you get to having several states that could be operating in parallel in a single chart. So the next thing you need to do is name your state. It's good practice to never use spaces in StateFlow for the names of a state. In our case, when we use RTI to build code for our controller, a space in a StateFlow block will crash the entire build and you have to start again. And what's really fun is when somebody names every single state in a StateFlow with spaces, and you have to go in and check every single StateFlow block in the entire code to make sure there's no spaces left. Sometimes it doesn't tell you which state has a space in it. So safest thing to do, don't ever put spaces in your StateFlow names. So I like to start states with a capital letter, even though my MATLAB stuff usually starts with a lowercase. MATLAB actually isn't all that particular about starting with an uppercase or starting with a lowercase, but it makes it really clear that that's a state and not an input or an output or anything like that. So I could have this as like the APU on, APU off, something like that. And then So the next thing that you want to do with your state is you might want to do something like perform a calculation or assign a value to something when you enter the state or during the state or when you exit the state. So there's, after the first line, if you just hit enter, the first line is always just going to be the name, nothing else. But after that is going to be essentially MATLAB code that runs every time you enter the state. It's going to check these things. So you can do entry and do out one equal in one. It's really important if you do an assignment like that you put a semicolon on it, because since it executes it like MATLAB code, if you don't put that semicolon, it's going to start filling up your display box on MATLAB. Yeah. So what the entry does, there's three different commands that you can put there. There's entry, there's exit, and there's during. So an entry statement, and you can do as many statements as you want after you put an entry. So I could say out one equals in one. I could say another thing of, come on. I could do out two equals into, stuff like that. Entry says that every time you enter this state, you're going to execute these commands. And so if I've got two states, and every time I enter this one, I want to perform some action or set some value, I would use the entry command. You have more than one, so could you have an entry and an exit for that? Yep, you can have as many entry, during, and exit statements as you want in a StateFlow state. So you have out one equals in one, out two equals in two, and then maybe during. So you would put during. And I think you can. I don't think you have to go entry, during, exit. I think you can do them in whatever order you want, but you want to make sure all your entries are together in one grouping, and all your exits and durings are together. So then during, you could do some other command, but I usually don't use durings. There's a couple of things. If you maybe want to have a timer output or something, you could use a during to basically constantly increase. Anytime you're in this state, increase something, and then once you leave that state, you stop increasing it, right? So if you wanted something like that, you could use the during command. On exit, maybe I want to trigger something every time I exit a state. So if I wanted to, I got a ton of emails. If I want to, every time I exit state one, I want to print something to the MATLAB workspace that says state one exited or something, you could do that. Or if you want it to be a trigger for other things to happen, either in StateFlow or in Simulink, you could have a output there so that when you exit the state and go to any other state for any reason, you set that. So then the next important. So does that make sense to you guys? Just the basics of how you get a state, how you can do things during an entry condition, a during, or an exit condition. All right, so the big thing about a state machine, though, is that you have multiple states. So I want to add a second state here. I'm just going to name it state 2. And you can see in newer versions of Simulink, I get this little error here. Not an error, it's technically a warning. But that warning is going to tell me that it's an unreachable state. So I have no way to get to this regardless of what code it's supposed to be executing. So what I need to do, if you bring your cursor over to the edge of a state, you can see I get the little cross. If I click and drag, now I've got a condition. So if you put an empty condition like that, what's going to happen is the default transition is going to put us into state 1. And then the order in which StateFlow does stuff is when you enter a state, it immediately performs the entry command. But then before it executes a during command, it immediately starts checking its output conditions or its exit conditions. And since I don't have an exit condition here, if I had a during condition in state 1, I wouldn't it wouldn't do anything because I do my entry condition or my entry command, and then immediately StateFlow would see that we, quote unquote, meet the conditions to exit the state. But really, there are no conditions to exit the state, so that's a problem. So if you double click on here, you got to put a square bracket. Some versions of Simulink add the square bracket for you, but can never remember which versions do it and when it does and when it doesn't. Always add the square brackets yourself is the safest way to avoid issues. So I want to put condition so I use a double equal because maybe you guys have done this in MATLAB, but the double equal is an equality check. It's not an assignment like a single equals is. But you can use less than, you can use greater than, you can use and or. Generally, if you're doing an and statement, you should use a double ampersand. And when you do an or, it's with the slash. But you hit shift, it's just the vertical bars. I have no idea what that character is called. Do you, Rishi?
Pipe.
A pipe? All right, cool. You put a double pipe. Learn something new every day. So that's an or statement. And I think if you're doing an and, if you have multiple ands and ors, you should always put parentheses around the statements that are supposed to be going together. If you don't, StateFlow will take everything into its own hands and figure out which one it wants to check first and stuff like that. In general, for an and, what it'll do is it'll check the first one, and if the first one is false, it won't even bother checking the other side of the ampersand. If you have an or and the first one is true, it won't bother checking the second side of the pipes because it knows that this statement is true because I already have one true. If you want to do a not, so not equal to or not and stuff like that, what I think is better to do is I would take, well, let me go ahead and delete the ampersand. Yeah, you can see it's already throwing an error because I didn't say anything. If I want to make sure that this is a not, I would put parentheses around it and put an exclamation mark. So that's the, is it exclamation mark or is it the squiggle? Is it the squiggle? I thought it was the exclamation mark. MATLAB it's the squiggle, but I think it's the exclamation mark in StateFlow. So what I'm saying is I prefer to do it this way because sometimes StateFlow doesn't like it. So not greater than, or stuff like that, or you want to do the opposite of an and or something. If you want to make a NAND, I don't think exclamation mark ampersand works. The squiggle works? Whatever. I'm not a MATLAB scientist. It's as long as it is a valid logical statement, StateFlow will be fine with it. I do suggest for ampersands and pipes for and or statements, always use the double, although I think it won't throw an error if you just use one, but always use a double and always group and or statements with parentheses to keep everything where it should be in your grouping, because it'll evaluate parentheses before it evaluates other stuff. That was a bigger tangent than I thought it was going to be. Oh, we're already 13 minutes in. So you can see, oh, object contains a syntax error. Maybe you're right, maybe you're right, maybe you're right. Haha, you were right, Rishi. So, for those of you watching at home, it is the squiggle. It's not the exclamation mark. So, too bad I can't go back and delete that. Anyways, so I'm going to get rid of that, though, because I don't want it to just... I don't want the not there. Ooh, crap. Just bleep it out yourself. Oh, come on. It is valid. All right. So, I'm going to have that condition. So the other things that you'll see here is a junction block. What the junction does, it's not an, geez, oh man. It's not an actual state, so you can't do commands in it. But what you can use it for is, say I want to have one condition here, but then I want to check another condition, and if it's true or false, I want to do separate things or go to separate states. I can check the one condition here, and rather than have like if A and B as one transition, and then if A and not B be another transition here to lead off to two states. It's not as big of a deal like this, but in some of our models we have 10 conditions for state transitions and stuff. So at that point, it's really nice to be able to group the common ones that have to be true for all of those transitions into a single node. But then from here, you could have one condition that brings you here, and maybe another condition that brings you to state 3. So this condition needs to be true for either of them, but then once we reach this node, we want to check these two. And you'll notice here it's giving me a warning with transition shadowing. So what transition shadowing is, neither of these have a condition. And so the problem is it will never do transition 2 because transition 1 is true all the time. The way to avoid this is if you're going to have a blank transition statement, you're not going to set a condition on it at all. You want that to be the very last in terms of number. And so if this has a condition, I forgot my double equal. And so you can see it added the brackets for me. A lot of the times when you use timers and stuff in StateFlow, it won't add it for you. It can be a real pain. Just make sure you put them there. So you can see now this is going to be a problem because I have a condition here that I want to check, but my default transition is shadowing it. So I don't want that. I want this to be transition number 2. And so when I do that, that should, there you go. So now it's no longer shadowing it because condition 2 gets checked on transition 1 here prior to it defaulting into transition 2. So this is acceptable, but I would suggest that you never leave something up to a default transition unless it's not a safety critical thing. So default transitions can be good if, say, you want to check all these things, but then at the end it's like, well, none of those are true, so enter this limp home mode or something. Yeah. So it is, if you guys have used switch cases before, not all of them may have. I love them a lot. If you don't already use them in MATLAB, they make running drive cycles a lot easier. I can show you how to do that. That's why you always want to leave it for last, is because you want to check everything else that you might want to see before you do your default transition. And so let me just add something here. So I'm going to leave that as a default transition, and then here I'm going to do condition 2 equals 1, and 0, 0. I want 0, and condition. I gotta watch my capitals. Condition 1 equals 0. There we go. So the reason I want to double check the condition 1 is equal to 0 before I do the transition is I don't want to hop over to right into here and then go into state 2. I want to make sure that before I do this state transition that I'm not immediately going to skip state 1. That's something that we have struggled with on HEVT at least, is if you transfer into a state but haven't actually checked the exit conditions for that state, you're just going to skip right through it. We had a problem before with waking up a controller where when we do the shutdown condition, we didn't make sure that all of the exit conditions for our off position were in the off state. And so the last thing that we should have checked is whether or not we had actually shut it down yet. And what we ended up having was this constant loop. And it'll throw a warning for that, but it'll still run because there's nothing invalid about just constantly running through a loop of states. That's something that you can actually visualize with StateFlow, which I'll show you in one sec. So I've covered entries. Let me just add an entry to this so we can see. Oh, but here's a problem. I didn't add an entry, a condition to this. I want to make sure that condition 1, 0. So now if I'm going to start in state 1. If I set condition 1 to 1, I'll transition to state 2. And once I turn off condition 1, then it's going to check if condition 2 is equal to 1. If it is, it'll go to state 3. If not, it's going to go over to state 1 again.
So we need to put, when you change in condition 1 and state 2, does that have to be an exit thing? Because if we do that with entry, we'll skip the rest of the state and go. Or does it do everything else that's in the state first before it leaves?
Before it leaves, it will do entry, but it won't do during. But if it immediately exits, it will also do its exit statement. And so if you have an entry and an exit statement, and you enter and then immediately exit, you'll see for one data point that you were in state 2, even though you immediately exited it, and then you'll see the exit condition happen. So, good thing to always check is that you're not just going to fly through a state. So, an exit condition it's good to make sure that it's similar things to the entry condition. If you have like a series of states that string along, like state 1, state 2, 3, 4, and then transition, and then state 4 is the only one that can loop back to state 1, then the loop back should check the entry condition for state 1, because otherwise you're going to go from, or for state 2, sorry, otherwise you're going to go from 4 to 2 without staying in state 1. This is all pretty general stuff. The StateFlow assignment that you guys are going to have, that's like a mini assignment, is just taking some data on speed ranges and nothing else. It's just speed ranges, and assigning a gear to that. So from 0 to 10 miles an hour, we want to have first gear, 10 to 20 second gear. It's not how a real transmission works, but it's going to be 6 states. You're going to have to check these entry conditions, and I know the messy way to do it in StateFlow, and I know the clean way to do it in StateFlow. So it'll be interesting to see what you guys end up with. Both of those functionally identical. Neither of them are going to cause any problems, but one of them is a lot nicer to look at. So, and runs more efficiently, but we're not at the point where we need to optimize our code yet. This is all still stuff our computers can solve in fractions of a second. So just to make this easier to visualize, I'm going to do an entry out 1 equals out 2, or into. I want into here. Recording again. All right, so we're 23 minutes in, so I went ahead and paused while I did this. So the last thing that I need to do is actually set up the inputs and outputs. I've named them out 1 and in 1 and condition 1 and condition 2 and stuff, but I haven't actually made it. If we go back up, chart 1 still doesn't have any I/O. So if I go up here to Model Explorer, and it'll default, if you're in a StateFlow, it'll default to that chart. So you can see I have my 3 states, and it has the actual code that goes in it and stuff like that. But you just want to go to the chart, and you want to go up to Add Data, which is up here. So you're going to add that, and it's going to default to local, but what we actually want to set it at, we want to have, in our case, we have 2 inputs, which are in 1 and in 2. We've got 2 outputs, out 1 and out 2, and then 2 additional inputs, which are our conditions. So we need an input named in 1, and now if we come in here, you can see it's already added in 1 for us. So I need to do that for 4 and then 2 more. So these ones I'm going to change to an output. I'm going to do out 1. I'm going to make another output and do out 2. So this is condition 1 and this is condition 2. So now when I go out, I've got, so you can see here the scope. Some of the other options are constant. That's something that's not going to change at all, obviously. Parameter is something that you can load from the MATLAB workspace if you want to just look directly at the MATLAB workspace for a parameter. But local is going to be something that isn't going to look at MATLAB workspace. It's not going to be an input. It's not going to be an output. It's something that stays just inside the StateFlow. Did we lose this room at 7? Hey, Andres. Because we're already at 26 minutes. All right. So with that, I can go back here. And as I come out, I got to expand this so you can actually see it. We've got in 1, into condition 1, condition 2. So for, come on, I'm going to grab some constants just to make this easy. Yes. So I've got a constant equal to 1, constant equal to 2. I've got 0, 0, and then I want to display the outputs.
I mean, it's up to you. What do you want to help?
All right, so now we're just going to set this to run indefinitely, and that'll make it super simple. And by super simple, I mean slightly complicated, but you know. So it's running infinite times. So if we go into StateFlow, it's going to highlight state 1 because that's what we're in. And now if I'm going to pause it really quick. I can edit these constants while we're doing it. So I'm going to change condition 1 to 1, right? And now, because I have it paused, it hasn't actually done the transition yet. So as I start stepping through, you can see it just jumped through condition 1 into state 2. And as I keep stepping it through, it's in state 2 because its exit condition is for condition 1 to equal 0. And now you can see our thing in state 2 is that you flip them. And you can see here that they are flipped. In 1 has been assigned to out 2, and oh, there is, crap. I gotta stop saying crap on this recording. All right, so you can see that, and then if I set condition 2 to 1, you can see it didn't actually jump yet because I haven't met the exit condition for state 2. And that's where nodes really help is condition 2 has changed, but I don't want to transition into state 3 until condition 1 is changed. So I set this to 0, and now you can see they're both 0. So now we're in state 3. And then it'll only transition once both of these are 0. So I set this to 0. We're back to state 1. So that's introduction to StateFlow. I'll send out the assignment. It's way simpler than it sounds because it's really just one input and then 2 outputs. It's going to be the gear number and it's going to be the gear ratio, which are defined by the gear number. So it's not really going to be that complicated. In terms of the I/O for the StateFlow, but setting up the logic properly to function correctly is where where the actual work is gonna go in. All right, so that's it for this StateFlow introduction, which was twice as long as I thought it was gonna be. There you go.